Hey guys, this is Mr. Murray. Getting ready to roll into scientific notation in our math class. And so before we get to scientific notation, which is pretty cool stuff and something we'll be talking about here in just a minute, we need to get an understanding of powers of 10 and what those are, what that means. This ties in real close to what we've been doing with exponents in class. Powers of 10 is just a fancy way for us to write numbers that are larger numbers. And the way we do that, we've been talking about powers and exponents. When we talk about powers of 10, our base is always a 10. And then the power just tells us how many zeros are going to come after it. So if I look at this, I put this table up here, 10 to the 6th power. If I write that out in factored form, that's the same as 10 times 10 times 10 times 10 times 10 times 10 times 10, 6 times. When I get to the standard form, the actual number that I'm talking about, that's a 1 with 6 zeros after it. Okay, so the 6th power gives us those 6 zeros, and that's 1 million. Well, the next one down, 10 to the 5th power, works out the same. That would be 10 times 10 times 10 times 10 times 10. Multiply the factor 5 times. When I get to the standard form, that's a 1 with 5 zeros after it. That's 100,000. Next number down, 10 to the 4th power. There's a pattern that hopefully you're starting to see here. I have 10 times 10 times 10 times 10. Now, if I go back, 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is going to be 10,000. That's a 1 with 4 zeros. 10 to the 3rd power, logically, is going to be a 1 with 3 zeros after it, which is 1,000. Ten to the 2nd power, a 1 with 2 zeros, gives us 100. 10. Now 10 to the 1st power, that's taking our factor 10. We're saying there's only one of them there. There's nothing to multiply. It just stays 10. This is where we get a little tricky though. If I have any number to the 0 power, 10 to the 0 power, well, you'll notice each time I'm dividing by 10, dividing by 10 here. So when I get 10 to the 0 power, I'm going to take the previous one, 10 to the 1st power, I'm going to divide it by 10. Well, 10 divided by 10, there is no factored form for that because there's no 10s there. But 10 to the 1st power, any number to the 0 power is going to equal 1. And then we can come back out here. Now this pattern keeps going even when we start getting into the negative exponents. 10 to the negative 1st power. Remember when we work with negative exponents, we actually have to take it and we flip it over so that our base becomes our denominator in our fraction. So 10 to the negative 1st power is 1/10. It would be written in decimal form as 0.1 or 1/10. And then the last one, 10 to the negative 2 power, negative 2nd power, that would be the same as 1/10 times 1/10. That gives us 1/100. These are something that we're going to be using as we roll into scientific notation, but having an understanding of how when the exponent gets larger, the value of the number gets bigger, and this is just a neat way to see how much bigger. Going as the negative gets smaller, or as the exponent gets smaller and even goes into the negative, it doesn't go away. It's letting us see numbers that are really small. So guys, there's power of 10. Hopefully that helps you understand it a little bit better.